System Conference is an annual technical event organized by the Department of Instrumentation and Control Engineering, Manipal Institute of Technology, Mahe Manipal. On behalf of the conveners and the organizing team, I, Ganesh Nayak, take this opportunity to welcome you all dignitaries, esteemed delegates, faculty, students, and guests to this inauguration ceremony. We would like to begin this inaugural with showers of blessing from above, and so I invite Dr. Bhagya S. Nawada to lead us into an invocation here. Can we get, yeah. I now request Dr. Bhagya to lead us into an invocation hymn.
Jaya Ganesha Gananath Dayanidhe Jaya Ganesha Gananath Dayanidhe Sakala Vighna कर दूर हमारे जय गणेश गणनाथ प्रथम धरे जो ध्यान तुम्हारो तिसके पूर्ण कारज सारे लंबोदर गजवदन मनोहर लंबोदर गजवदन मनोहर कर त्रिशूल परशुवर धारे जय गणेश गणनाथ रिद्धि सिद्धि जो चमर धुलावे मूषक वाहन परम सुकारे ब्रह्मानंद सहाय करोनित ब्रह्मानंद सहाय करोनित भक्त जनों के तुम रखवारे भक्त जनों के तुम रखवारे जय गणेश गणनाथ दयानिधे सकल विघ्न कर दूर हमारे जय गणेश गणनाथ गणनाथ गणनाथ.
Thank you, Dr. Bhagya. The Department of Instrumentation and Control Engineering is ably headed by Dr. Srisha C. Sir. May I now request you, sir, to extend a formal welcome to the gathering.
Good morning. Dear Dr. Commander Anil Rana, President of the function, Dr. Giridhar Kini, Registrar, Mahe, Mr. Santosh Gosavi, General Manager, Tata Motors, Mr. Satyanarayana, Group General Manager, MRP of Bangalore, Dr. Ramakrishna Kini, Convener of the program, my dear colleagues, students, participants. It gives me immense pleasure to stand before you and welcome all of you to this 20th Control Instrumentation System Conference, which is a flagship event of Department of Instrumentation and Control Engineering, MIT Manipal. To this conference, when we are finding the suitable speakers and the guests. Being a electronics instrumentation BTech program offering department and called as instrumentation and control department, we are searching for eminent personalities who are working in the domain, who can inspire our students and possibly give us some opportunity for collaboration. So at that time, I have been fortunate to get connected with Mr. Santosh Gosavi. He is General Manager Testing at Tata Motors, Pune. And we requested him to be the guest and also to inaugurate the conference and also deliver a keynote address. He readily agreed with our request and made it possible to come here and physically present himself for this inaugural function, and later on he is going to give us a keynote address. So on behalf of the department and MAHE, I would like to extend a very formal, hearty welcome to you, sir. Mangalore Refinery and Petrochemical Limited is very close to us. Some of our faculties are collaborating with them. Our students regularly go for internship there, and many of our alumni are working there as engineers, and we are fortunate to have Mr. Satyanarayana HC, Group General Manager, MRPL, Mangalore, as one of the guest of honor today. Sir, on behalf of the department and the MAHE community, I extend a warm welcome to you. All our activities are very ably supported and guided by our administrators, and many times we are doing some mistakes in doing our procurements or arranging some finance aspects. So whenever we request for any favor, any what you call ratification after the incidents, our registrar is always supporting us. Even otherwise, when we follow the procedure, there won't be any issues. But sometimes we need to have some extra support from them. Then they are readily supporting us. So all our events are going to be a successful events, and we are getting motivation for doing such many events because of the able support from the MAHE. I, on behalf of the department and the institution, welcome our registrar, Dr. Giridhar Kini, for this inaugural. Our Director, Commander Anil Rana, always inspires us by his motivating words. Never gets angry even though we are not meeting his expectations. He pats us and encourages us to do good in the next future events. So with this motivation and encouragements, we are able to conduct many programs in the department. Sir, we are fortunate to have you with us today. I welcome you wholeheartedly to this inaugural function. Being HOD, conducting such events definitely takes a lot of time and effort. But I am fortunate to have a good team with me. Many of the things, just by informing that has to be done, somehow the team in the department are ably doing that. Very little intervention from my side is required. I welcome my convener, Dr. Ramakrishna Kini, and co-convener, Dr. Anish Acharya, for ably organizing this event, and I welcome them to this inaugural function as well. Entire team ICE is supporting the activities, faculty, non-teaching staff, and the students, and all of them who are having done supporting work to the conduction of this event are present here. I welcome all my colleagues, students, and research scholars for this inaugural function. Any event of this nature is successful only with participation from the presenters or the contributors for the research papers. We have got overwhelming support for this event. Almost 160 above papers have been submitted and we have selected about 56, and out of that about 47 or 48 participants are registered. Few of them are on the physical mode, they are present in the paper, and few will be in the online mode. We are conducting in a hybrid mode. I welcome all the contributors to this conference and also with them all the best in the deliberations. With their invitation, many of our head of the departments, associate directors and administrators have participated in this inaugural function. I extend a warm welcome to each one of them. Once again, I welcome each and every one of you and wish the conference every success and wish the participants all the best. Thank you.
Thank you, sir. I now call upon the convener, Dr. Ramakrishna Kini, to give an overview of CISCON 2023.
So dignitaries on and off the dais, delegates, HODs, my colleagues and dear students. So good morning to one and all. I am here to give an overview of the CISCON 2023 conference. So as you are all aware, the CISCON conference was started in the year 2004 in the Department of Instrumentation and Control Engineering with the intention of giving exposure to final year students in the areas related to their curriculum. Since then, CISCON has become an annual event in our department by giving a platform to address key issues in control areas, instrumentation and other related areas through deliberations and keynote talks from experts in industry as well as academia. So this year the department is organizing its 20th CISCON conference, which will be in the hybrid mode. So we are privileged that the conference is supported by reputed government agencies like CSIR and DRDO, and ARK Info Solutions is the industry partner for the conference. So this year we have received around 162 original research papers by UG PG students, research scholars, faculties and scientists from various research laboratories across India, out of which 56 manuscripts have been accepted for presentation and 47 participants have registered for the conference. So out of the 47 registered papers, 14 papers will be presented in offline mode and 33 papers will be presented in online mode. All the registered and presented papers will be published as book chapters in Scopus Indexed, Springer Lecture Notes in Electrical Engineering. So we have received papers from many premier institutions across the country, which includes IIT Patna, VIT Vellore, BITS Goa, NIT Trichy and MU Jaipur. All the papers will be presented in parallel technical sessions today and tomorrow, and we are divided into 7 different sessions, namely controls and instrumentation, robotics and electrical drives, IoT and electronics, communication, biomedical, deep learning and machine learning. So the chief guest for today's function is Sri Satyanarayan HC from MRPL Mangalore, and soon after the inaugural he will be delivering a keynote on the topic looking forward in the industry for instrumentation. The guest of honor for today's function is Mr. Santosh Gosavi, who will be again delivering a keynote after the inaugural on the topic a digital transformation in automotive industry. Today afternoon we have a guest lecture by Professor Sudesh Sivarasu from University of Cape Town, South Africa, and his topic will be exploring medical device life cycle through instrumentation and control lens for its adoption in GMP. Tomorrow morning we have another guest lecture by Professor Ram Mohan Reddy from NIT Surathkal, and his topic will be AI based decision making frameworks for smart applications for some case studies. I hope that all the participants, our colleagues and students will participate in all the guest lectures as well as technical sessions in the next 2 days. So with this, I wish all our participants a fruitful deliberations at the conference and hope it becomes a memorable experience for one and all. Thank you.
Thank you, Dr. Ramakrishna Kini. The organizing team is honored to have Mr. Satyanarayan HC Group General Manager, Technical Service MRPL Bangalore, as the chief guest for this inaugural. I now request Dr. I.T. Arasu, Professor, Instrumentation and Control Engineering Department, to introduce the chief guest to the gathering.
Good morning. Sri Satyanarayana HC is an engineering graduate in instrumentation technology from Mysore University, also postgraduate diploma in marketing. He is having an experience of 33 years in various areas of petrochemical and refinery industry. Have handled projects, maintenance, production planning, international trade, marketing and technical services. Presently working as Group General Manager, Technical Services in Mangalore Refinery and Petrochemicals Limited. Currently he is heading Process Engineering, Inspection and Design, Quality Control, Production Planning and R&D sections of the refinery. He has earlier worked in Tata Consulting Engineers and Indian Petrochemical Corporation Limited as well. With this introduction, I present you before
Ever since the beginning of creation, light and brightness have always been equated with knowledge, wisdom, positivity, and motivation. A single lamp can light 100 more. Likewise, this is true with knowledge that increases when shared with or imparted to others. I now invite the dignitaries on the dais for lighting of the lamp. It is now my pleasure to introduce to you all Dr. Abhay Pashilkar, Director NAL, who couldn't be with us today due to other commitments. Dr. Abhay Pashilkar completed his BTech Honours in Aerospace Engineering from IIT Kharagpur and ME in Aerospace Engineering from Indian Institute of Science, Bengaluru during the year 1993. Post this, he joined the Flight Mechanics and Control Division, National Aerospace Laboratories. Since 1993, he has worked on various projects like the LCA and SARAS. Further, he completed his PhD from IISc Bengaluru in 2002. Dr. Pashilkar was with the NTU Singapore for his postdoctoral fellowship from 2003 till 2005. Dr. Pashilkar was the group head, flight simulation in the FMCD division from 2008 till 2016 and its deputy head from 2014 till 2021. From 2018, he was heading the System Engineering Division of NAL and was appointed as the Program Director for Civil Aircraft Programs at CSIR NAL. He is the recipient of the 1997 NAL Young Scientist Award, 2001 CSIR Young Scientist Award, and 2003 INAE Young Engineer Award. He resourcefully coordinated the Mirage upgrade project for final operating clearance, which received the CSIR Technology Shield during the year 2019 from the Honorable President of India. He has guided 6 PhDs and has over 30 papers in national and international journals. His areas of research include flight dynamics modeling and simulation, parameter estimation, flight control, and human factors in aviation. Dr. Abhay Pashilkar, an eminent aerospace scientist, took over as the director, CSIR-NAL, in the month of September 2022 and continues to contribute towards India's civil aviation program. Dr. Pashilkar has shared a video with us, which I will now play with you all.
Good morning. This is Dr. Abhay Pashilkar, Director CSIR National Aerospace Laboratories. Mr. Santosh Gosavi, Tata Motors. Mr. Satyanarayana, MRPL Mangalore. Mr. Giridhar Kini, Registrar Mahe. Dr. Anil Rana, Director MIT Manipal. So it is indeed a pleasure to be here at the CISCON-2023. This is the 20th Control Instrumentation Systems Conference. I understand this is an annual flagship conference organized by the Department of Instrumentation and Controls Engineering, and this event has been going on every year since 2004. First of all, I understand that the organizers have invited various original articles in the field of automation, biomedical instrumentation, electrochemical sensors, optical biosensors, and many other areas like wireless sensor networks, linear and nonlinear control theory, multi-sensor data fusion, image processing, computer vision, and in the more recent areas like machine learning, robotics, mechatronics, embedded systems, and so on. So I understand that this is now a platform for researchers, industrial fraternity, and academia to come together and deliberate and exchange problems and ideas in the latest trends in instrumentation, control, and systems engineering. In fact, I commend the organizers for including systems engineering, very important discipline going forward. I also recall my association with Dr. T.G. Pai, Technology Director of the Aeronautical Development Agency, during the early days of my association with light combat aircraft as part of the National Control Law team. And we undertook lots of high angle of attack spin studies for the LCA, light combat aircraft Tejas, and also my association with Dr. Yoganand Jepu, who was a colleague and a scientist. We worked together in the same National Control Law team for the light combat aircraft. So going forward, I understand that in various areas, about 160 papers have been received, out of which about 56 have been selected, and all of them will be published in the Scopus Index Springer Lecture Notes in Electrical Engineering. Further, there is a best paper award in each session. So I would like to commend the organizers for really raising the bar of this conference and providing support to all the students and researchers in this very important area. So with that, I declare this particular CISCON 2023 open. Thank you and Jai Hind.
And now invite our chief guest, Mr. Satyanarayana HC, to address the gathering.
Good morning, everybody. Dr. Rana, nice to be with the defense background personnel always. Mr. Kini, Mr. Gosavi, Mr. Shisha, Mr. Kini again, and students and teachers and the presenters who are watching in the VC. It's always a great pleasure to be in a campus like MIT. This is my first visit, even though I am here in last 30 years in Bangalore. This is my first visit to MIT. The first thing that struck to me was the campus. I remembered my campus of SJC, and also a similar program that we had organized in instrumentation department, wherein we had invited all the students and the industry members to come and present their wares. And just I went back to those years, which were fantastic years, and it's always a not so easy job to organize such a conference, and I should congratulate the Department of Instrumentation Technology or Instrumentation and Control for organizing such an event, which will definitely benefit the students greatly, because those days when we had invited people, we did not have those many interactions between industry and media, academia. But these days, I think definitely we have a lot of interaction, which will definitely prepare the students going forward into the field of industries and their career, and they will have a better idea of what is going to be there in the future and what they can choose, what they have to learn to go to some interesting field of their own choice. So it's always a great thing for attending such a conference. I am very personally grateful for inviting me to be here in the midst of you and enjoying my old memories going back to the college days. And it's always nice to be in that position rather than this position, I can tell you. So always enjoy these days, learn a lot of things, be open, and take care of your studies. Thank you.
Thank you, sir. I request our Registrar Dr. Giridhar Kinney to present a memento to our chief guest. I now request Dr. Meenakshi Sundaram, Additional Professor, Department of Instrumentation and Control Engineering, to introduce our guest of honor, Mr. Santosh Gosavi, GM and Head, Indoor Testing, Tata Motors, Pune.
Good morning. It's a pleasure and privilege to introduce Mr. Santosh Gosavi, the General Manager and Head, Indoor Testing, Engineering Research Center, Tata Motors Passenger Vehicle Limited, Pune. Mr. Santosh Gosavi has obtained his graduate degree in electronics from Pune University and postgraduate in automotive electronics from BITS. He has over 25 years of experience in design, development of automotive systems and component. His expertise includes performance attribute management, digital product development, instrumentation and road load data acquisition, product testing and validation. He has over 12 technical papers and articles in various national and international journals and symposiums, and he also holds 19 patents and 12 copyrights to his credit. With this brief introduction, now I present Mr. Santosh Gosavi.
I now request Mr. Santosh Gosavi to address the gathering.
So, good morning to all the dignitaries sitting on the dais, faculty members, and the dear students. Actually, it's my pleasure and honor to be here today to be part of this annual gathering, CISCON-2023. I would like to first congratulate the organizing team, faculty and students for putting this together, the 20th event of CISCON 2023. And it's also my pleasure today actually sitting among all the doctors on the dais. So it gives an immense pleasure me to actually interact with all of you and the dignitaries on the dais. So as an engineering student, you are the future of nation and the world as well, because today the boundaries are diminishing and the opportunities for each and every to practice, to experiment and get the innovation in the area of technology. As an engineer myself, I know how important it is to keep the pace and follow the developments in the science and technology. So this conference is a great opportunity for you to showcase your talent, learn from peers and interact with experts. See, engineering is just not a profession, actually it's a passion. This I can tell you because being an engineer, I started my career with the very basic activities like I used to test strain gauges on the systems and components, the performing different measurements on the test benches, on the test vehicles. So that's how the initial career I have started with. And now, after having learned through the experimentations, it's an opportunity to explore that knowledge in the digital development. That's what the today era is. So that's what I can say. Please explore, experiment without any fear of failure. The success will come. Okay, thank you and all best wishes.
Thank you, sir. I request our director, Commander Dr. Anil Rana sir, to present a memento to Mr. Santosh Goswami sir. I now request Dr. Gurudas Nag sir, Professor, Department of Instrumentation and Control Engineering, to introduce our other guest of honor, Dr. P. Giridhar Kini, Registrar, Manipal Academy of Higher Education, Manipal.
Good morning, all of you. Today I am introducing Professor Dr. P. Giridhar Kini, Registrar, Mahe, Manipal. Dr. Giridhar Kini completed his BE in Electrical and Electronics Engineering in 1995 and MTech Engineering Management in year 1998, both from MIT Manipal from Mangalore University, and obtained his PhD degree from Mahe, Manipal in the year of 2008. Dr. Giridhar Kini started his academic career by joining his alma mater, MIT Manipal, as a lecturer in the year of 1999, and since then he has served MIT and Mahe in various academic and administrative capacities. He was deputed to Manipal University, Jaipur in the year 2012 and also served as the head of the Department of Electrical and Electronics Engineering, School of Electrical Electronic Communication Engineering, MU, Jaipur for a short period. During this tenure, he was instrumental in setting up the various UG and PG labs of Department of Electrical and Electronic Engineering at MU, Jaipur. Dr. Giridhar Kini served as an Associate Director, Industrial Liaison and Placement Practice School, MIT Manipal from June 2013 to December 2017. During this tenure, he established a high industrial connect for UG and PG practice school in addition to full-time placements, leading to significant improvement in the number of Fortune 500 recruiters visiting MIT Manipal for internship and placement opportunities. Dr. Giridhar Kini also served as a Director Admission Mahe from January 2018 till November 30, 2022. During his tenure, the Mahe admissions team assured a smooth admissions process even during the pandemic period. Dr. Giridhar Kini has credited 15 publications in various national and international journals. With this brief introduction, I am introducing Professor Giridhar. Thank you.
I now request Dr. Giridhar Kini sir to address the gathering.
Dignitaries on the dais, faculty members of the Instrumentation Department, dear students, the delegates who are also online, a very good morning to all of you. 20 years is not a, it's not a simple task. We have seen many conferences. I've been witness to many conferences which have started, and some of them have disappeared without a trace. But 20 years is, it's going strong. So, I would like to congratulate the Department of Instrumentation Engineering for maintaining the visibility of the institute as well as the university in ensuring that the culture which was started in 2004 even continues today. Now, as Mr. Satyanarayana mentioned, organizing a conference is, it's not an easy task. A lot of things are involved, right from planning, scheduling, dates, examinations, labs, everything. Including identifying the guests. So it's not an easy job. But we need to understand the benefits of it more than looking at the issues in conducting a conference. For the faculty, of course, for the university and the institute, it's about the visibility in terms of getting external delegates and people into the campus, more of a perception building exercise. For the faculty, it's more about learning the organization skills and, of course, ensuring that whatever work they are doing in the department as part of the research activities also get highlighted, in addition to the networking, creating more opportunities for research, identifying more areas. But the best benefit always goes to the students. Today you are part of this department, you are studying. Tomorrow you'll get into the corporate world. You'll also do all these kinds of activities there as well. The difference would be then if you take part in organizing events within the institute, you can always fall back on your experiences and do a whole lot more better when it comes to organizing events as part of your employee profile. So that way it's going to add a lot of value. This is from the organization point of view. Whereas from the research point of view, most of us always look to go for higher studies within the country and abroad. Identifying an area of interest will always help you in trying to take the areas, your expertise to the next level, from the engineering projects to your internship projects to your master's projects, or finally your research areas if you are going for the next level, PhD. So if you plan that well, you can always start from the engineering days. So if you have made an attempt to present your papers, attach or tag along with a faculty to take it to the next level, present a couple of papers, that will give you enough confidence so that when you go for your masters, you can, as I said, you can always fall back on your experiences. And a couple of papers to your name will always add a lot of value, even when during the master's projects as well as the research areas. And of course, now the university has opened up for part-time PhDs. I'm sure, sir, learning is not too late. You can still register for part-time PhD at the institute. Definitely will. And your experiences will also add to the department, institute, and the university as well. So this is, and for the students as well, you are our potential part-time PhD students. So please look at the areas within the institute, across the departments and the university, so that once you get into the profile of your choice, maybe 4 or 5 years down the line, you can always look at the next big leap to in the academic career. PhD is the highest point which you can always achieve. You can always have multiple masters, and very rarely you will have people doing multiple PhDs. So I think this is a great opportunity to not only learn event management, but also look at getting into the research domain, so that your future career will always be on the next level. So once again, congratulating the instrumentation department and the institute for maintaining the standard of research. You are looking at only presentation of 55 papers, and almost 1/3 of the papers have not been considered, if I'm not wrong.
Yes.
So that means that we are not conducting the conference just for the sake of numbers, or not simply for generating the revenue, but maintaining the quality is more important than looking at just the quantity. So once again, congratulations to the institute, department and the conveners involved, and for keeping the flag flying. Wishing you all the best, and thank you very much for the opportunity.
Thank you, sir. I now request Dr. Sureka Kamath, Professor, Department of Instrumentation Control Engineering, to introduce our Director, Commander Dr. Anil Rana.
Dignitaries on and off the dais, very good morning one and all. It's my privilege to introduce President of today's function, Director Dr. Anil Rana. Dr. Anil Rana has over 30 years of experience in the industry and academia. Prior to his academic service, he served as a commander in the engineering branch of the Indian Navy in various roles. He has a PhD in reliability engineering from IIT Mumbai and MTech from IIT Delhi. Post his naval service, he served as Associate Dean Research and Professor of Mechanical Engineering Department in Fiji National University in Fiji Islands for 5 years, followed by Dean Academics and Professor in Symbiosis Skills and Open University, Pune. He was the Dean Faculty of Manufacturing Skills and Dean Academics in BSDU Jaipur before taking over as Vice Chancellor of Oriental University, Indore in February 2021. His research interests are in the field of reliability engineering, maintenance engineering management, stochastic petrinets, machine learning, fuzzy and neuro-fuzzy applications in the field of maintenance engineering. He has a long list of publications in international and national journals, including Springer publications. With this brief introduction, I welcome Dr. Anil Rana sir to address the gathering.
Thank you, madam. Firstly, I'd like to apologize. I'm still recovering from viral fever, and my voice is very hoarse. Otherwise, I generally sound very sweet. This one always works. Chief guest of today, Mr. Satyanarayan. Guest of honor, Mr. Santosh. Registrar Mahe, Dr. Giridhar Kini. HOD, Dr. Shisha, Mr. Ramesh Kini. Thanks, Ganesh, for holding the deck there. HODs, researchers, faculty, colleagues, and my dear students. Firstly, I'd like to compliment the Department of Instrumentation and Control Engineering for conducting this 20th conference, CISCON. And I also like to thank the generous sponsors and the industry partner for this important conference. For the students, this is very meaningful. It should be very, very beneficial. If you want to search on the net what are the latest advancements in the field of control engineering and instrumentation engineering, you will get hundreds and thousands of results. It will be very difficult for you to actually make out what is new and what is not. This is one platform where you have 160 plus papers which have come in, and they select 50 plus being published can give you a very nice bird view of the advancements of the area where new developments are happening. I have spent a long time in the Navy. I have seen how the control systems have evolved on a naval platform. When I started when I was very young, maybe younger than you were, we used to have mostly mechanical and mechanical pneumatic systems. It moved to electro-pneumatic to electro-hydraulic and then became the digital control. Earlier used to have large number of technicians working below the deck for you to ensure that the engineering systems of warships are working. There used to be errors, there used to be failures. As the advancements happened, the number of people required on board a platform like that started reducing. But at the same time, the complexities increased. Now, if you look at a new warship, which are stealth warship these days, which emit very less signature, so detection is difficult, you will be amazed to see that the guy who's sitting in a control room of a warship, especially an engineer, got many things to handle much larger in number than a pilot handles on an aircraft. It's huge. So therefore, the kind of knowledge that is required to operate such systems have also become huge. The requirement of very long training, both in the classroom and outside the classroom on a platform, has become very long and important. But with this complexity, what has come is increase in productivity, reduced errors, and reduced operation cost overall. There is a small joke I would like to tell you here. In the morning when we were sitting with the chief guest and the guest of honor, I was telling them about my experience that I had gone to Russia once. And those days, it was to get those new stealth frigates. Now for the first time, the Russians were making a frigate that they were not operating. That means their navy did not have those ships. The earlier versions were whatever they used to have, they used to sell. So they were experts in the systems. So it was easy for them to hand it over to the next naval team, whichever, Chinese or Indian mostly. Now was the time where they were first hand having an experience of a very modern platform which they never operated themselves. And how it used to happen is, we were supposed to work with them for a month. Before that, we were all trained together. Then they will operate the ship. And after a month of trials of each and every system, they will hand it over system by system to the Indian naval counterparts. So I had this very senior engineer sitting there on the platform, starting his gas turbines. So his gas turbines are like jet engines, mostly. So these engines have every few seconds some or other operations which are supposed to start so that the gas turbine starts properly. When he was preparing, every button that he presses on the panel, on the digital control, he would quickly ask a youngster, come here in Russia. And then he used to say something, this guy used to go running down in the engine. This guy would keep waiting. There will be some signals which will be popping up on the screen, but this guy is like coolly relaxed. Till the time that youngster came back sweating, saying, done. Then he used to do something, again, go ahead. This was happening for some time now. I had to ask this, I said, what are you doing? He said, I don't trust this system. So a mechanical engineer, for him, the digital control was something he didn't trust because he had no experience on that. And believe me, after that we have operated their system. We are trusting the system because we know it works. The Russians had a tough time operating that. There are a lot of failures. In fact, there were more failures when they were running than after they have handed over to the Indian engineers who are running the ship very successfully and now manufacturing inside India in Mumbai. What I am trying to bring out here is the change that is happening, the advancements that are happening are so rapid that we need to really be alert to keep up with the changes. All those students who are here, it is very important for you to see what are the papers being published in these conferences. That will tell you as to where the new changes are happening in this particular field. The new developments that are happening, wherever it is happening, it is about automation, it is about control. And that is not going to go away. In fact, it's going to become only more important. We find divisions that are there which divides our own departments are becoming blur day by day. So what was in the domain of information technology or in an electronic system is now your domain too, because that has come into the control engineering system. The application of machine learning or AI is everywhere. It is very, very important for you to understand that changes is something which is going to be constant, and if you don't keep yourself updated, you will be lost very soon, and then you will not understand as to what is happening around you, and it will take very long time for you to keep up and update yourself. So therefore, make use of this particular conference, look at all the papers, look at or hear out the speakers, ask doubts, get your doubts clarified. It will not be possible for you to learn everything that is happening. But even if you are aware of what changes are happening and based on your own interest, if you want to go further, you can then dive deep. Make use of this particular moment and opportunity with the experts here. Talk to them. Don't leave them aside. Don't leave them in the corner talking to only HOD and director and joint director. You come in between with your cup of tea and talk to them. Find out what changes are happening. See what you can get. Your guest of honor is coming from a Tata Motors R&D center. I'm sure they are doing some amazing stuff over there. Happy learning to all the participants. Thank you. Jai Hind.
Thank you, sir. In spite of you being ill, you've taken the time to be with us and motivate our students. Thank you so much. As we come to the end of this formal ceremony, it is now time to express a word of gratitude to everyone who has supported us. I request our co-convener, Dr. Anish Acharya, to propose the vote of thanks.
Good morning, ladies and gentlemen, respected dignitaries and audience. It is my immense pleasure to propose the vote of thanks in CISCON-2023 inauguration ceremony. Any event would not be fulfilled without thanking those who worked for it, and it is time to acknowledge them. The idea of CISCON is to spread academic excellence. The presence of our invited speaker greatly enhanced this. At this juncture, we would like to thank Mr. Satyanarayana HC, Manipal, Mangalore, chief guest for the inaugural function. Sir will also deliver the keynote address after this inaugural function. Thank you, sir, for accepting our invitation and being with us today. We would like to thank Mr. Santosh Gosavi, GM and Head, Tata Motors, guest of honor for this inaugural function. We are truly inspired by your words of wisdom, sir. His keynote address will be at 11:30 a.m. in this seminar hall. Thank you, sir. On behalf of the organizing committee, I would like to extend my heartfelt gratitude to our registrar, Dr. P. Giridhar Kini, Mahe Manipal, for kindly accepting our invitation and gracing the inaugural function. Thank you, sir. Dr. Abhay Pashilkar, Director of CSIR, National Aerospace Laboratories, Bengaluru, gave the inaugural address to the August gathering through his video message. Your recorded presentation has added a lot of value to our event. Thank you, sir. I would also like to thank our beloved Director, Commander Dr. Anil Rana, for his wholehearted support and encouragement. Thank you, sir. I would like to thank our Head of the Department, Dr. Shisha C, for his throughout encouragement and support in organizing this conference. Thank you, sir. We are privileged that this conference is supported by reputed government agencies like CSIR and DRDO. ARK Info Solutions is the industry partner for this conference. Thank you for our sponsors. Thanks to the associate directors, head of the various departments and faculties who spared their time to grace this occasion, and those who are watching this program through live streaming. Special thanks to Dr. K. Ramakrishna Kini of CISCON-2023 for his all-around support and hard work. Thank you, sir. I take this opportunity to thank all the session chairs who will spare their valuable time to chair the technical sessions. Special thanks to all reviewers and the Springer editorial board. The delegates are the backbone of this conference. I thank all delegates present in this venue and the delegates from different parts of the country for being present online, and I hope they will have a fruitful interaction during the conference. A conference needs coordination and commitment. We are fortunate that MIT and MAHE administration for timely logistic support. Thanks to the security section, the audio-visual department, the Chief Warden's Office, Food Court, BQMS, and the MAHE Finance section, ME Seminar Hall in charges, who have provided immense support in organizing this conference. Thanks a lot to everyone. And finally, thanks to today's Master of Ceremony, Professor Ganesh Nayak, the organizing committee members, my colleagues, students, and non-teaching staff of our ICE department. Special thanks to our students and volunteers who are witnessing this inaugural function. Finally, I would like to thank all of you present here for making the time to be with us today and helping us make CISCON 2023 conference a grand success. Thank you one and all. Thank you all for your present and patient listening. Have a fruitful learning and a wonderful day ahead.
Thank you, Dr. Anish. We are at the end of this formal inauguration ceremony, marking the beginning of the conference. I, Ganesh Nayak, wish the delegates, students, and everyone else a fruitful 2 days of interaction and knowledge exchange during the sessions that are to come. An informative keynote address will now be delivered by Satyanarayana Hetsi. I kindly request the students to be seated.
Should I start? Once again, very warm good morning to all. I kept my speech in the beginning for a few minutes only, because I knew I'll be eating your brain for another half an hour later. So, first of all, again, it's an honor to be here as a chief guest and be here to present whatever I have learned or whatever I have seen or whatever I want to view going forward. The world we live today is evolving at a very unprecedented pace and driven by technological advances, and things are transforming to a great extent. You know, the amount of changes that is taking place is so fast that something that you have today becomes obsolete tomorrow. It's becoming like that. And it's actually reshaping our lives and how we live and work. Especially in the field of instrumentation and control. The day when I started my career, when we had studied some 80-85 processors and things like that in our colleges, and when we went there in the field, when I started my career as a instrument engineer in Tata Consulting Engineers in Bangalore, we were doing some consulting services for power plants. You know, so that was just from the college papers to the office papers. You know, consultancy is more of doing work on the table, and as a fresh student, you would not be able to really appreciate what you would be able to do as a consultant, because you yourself is new and you yourself don't know what are the things in the field in instrumentation, and you are supposed to do some consultancy work. Of course, you would learn going forward in the job, but once you go, I changed my job for that purpose to get into a field where I wanted to physically see what is instrumentation, what is a transmitter, what is a control valve and things like that. So I changed my job to Indian Petrochemicals Corporation, where it's totally a field job, where I joined as a graduate trainee and continued in the maintenance department. There, what we saw was a lot of at that time, what we thought was a lot of development in technology from what I was reading. And when I went there, we could see still, from the present stage, a lot of pneumatic systems. As Dr. Rana was telling about his experience, the DCS had just come there, the distributed control system. And even then, the development was not that fast. The DCS itself used to be valid for, let us say, 10 years. You know, whatever DCS you put, it was valid for 10 years. And the technology of the DCS itself was different than what it is today. So how we are operating, how the controllers are operating was totally different. So what I'm trying to say is that the things are changing faster than what it was earlier. So that is making a lot of transformation like never before. We are into the fourth industrial revolution, or what we call Industry 4.0 and things like that. This revolution is not just about machines, it's about the convergence of the physical, digital and biological worlds. You know? So I would just like to tell you all about what we have seen in this change in the industry technology and the revolution that is taking place, because a lot of things have blurred between digital and the physical realms. Imagine the factories that are not just smart. Smart was something which was very a word which was in vogue for a long time, but these are now become intelligent. You know, they are not just smart; they have become intelligent. The factories can start thinking and adapting themselves and optimizing the process autonomously on their own. You know, can you imagine that? And just a simple example is that your car. You know, earlier you used to have a car which had a mechanical gear system and all those things, but now you have auto gears, auto gas has become a passe. Now you have something which is map which has come up on your car. You can put your location where you want to go, and it will tell you the route. You don't have to think about the route also. And now you also have something which is driverless car. You have to just sit there. Earlier, from a gear-driven car, you have become reached a place where the car will take you. You have to just sit there. And I'll not be surprised if tomorrow it will tell you where you have to go tomorrow. Okay, it will tell you in the morning 9 o'clock you have to go to your office in this route, and you decide, and it will decide on its own. So things have changed, so they have become adapting themselves to where the technology is changing so fast. So what are the components? What are the things which are changing all these things? The Industry 4.0 includes a lot of things like Internet of Things, sensor networks, AI, ML, which all of you will be aware by now, and big data, which is the major thing which is going to rule the world, I feel, in the next few decades, and analytics of those things. So these are the things which are going to be combining themselves and bringing up new technologies, and these will be creating a manufacturing landscape where machines can communicate, adopt, and optimize themselves. And why these are happening is they have to reduce the time, they have to increase the efficiency. That is the main aim. With these things, will join together and achieve basically what is they are reducing your time, reducing your efficiency, improving your accuracies, right? So these are the changes which is done. And I'm sure these days of internet, obviously you will be, I don't know how many of you will be using ChatGPT. And some of you are using? Yes. As an expert, okay, in the college. Okay. So ChatGPT, yes, it's a good thing that helps you in achieving things which you would have a faster rate than you would have taken otherwise. It basically finds you out the data that you want and puts it in the format that you want very fast. But it all depends on what you're going to ask, what you're going to. It's basically going to search on the net, which otherwise you would have done manually. So, but the thinking process, what to ask, it is not yet come. What you want to ask, that will also come, I feel, after some time. That what you want to ask also will be there, and then it will do everything on its own. So, Internet of Things, coming to the instrumentation part, Internet of Things and wireless sensors has gone into many sectors, and the way it has revolutionized the way the data is collected and utilized. In agriculture, for instance, instrumentation is one field where you should all be happy that you can get into any field. You don't have to be worried like a chemical engineer. Chemical engineer would be, let us say, will be a process industry based or R&D. There are 2-3 fields. Whereas instrumentation is required everywhere. Whether it's agriculture, whether it's a medical, whether it's a chemical, whether it's a mechanical field or a civil engineering field, everywhere you will have measurements. Wherever measurements are there, instrumentation guys will be there. So you can all be very happy that you have chosen a good course for your future. So if, for example, in the IoT, where wireless soil sensor moisture sensors have come. So they provide the real-time data for the soil conditions, helping farmers optimize the irrigation and conserve water. In healthcare, IoT-enabled wearable devices monitor patients' health, vital signs, etc. This will transmit the information to the healthcare providers, allowing more remote patient monitoring and timely interventions, which is very much required as we move forward. In smart cities, obviously there are a lot of smart cities coming up in the country as well as abroad, and they allow for your embedded infrastructure, traffic monitoring sensors and the devices which can give you a lot of information on environmental conditions, how these smart cities have to have, how they have to be with respect to environmental monitoring, energy consumption. Energy is something which is going to be the focal point for everybody, whether it's renewable energy or the normal fossil fuel energy. Everything will be focused on energy savings, how to optimize. So all these things, IoT-enabled sensors will be very applicable. And of course, the machinery machines, Mr. Santosh should be able to tell more on that, because these machines will have the IoT-enabled sensors which give us information for predictive maintenance, and insights, so that we can reduce the downtime of the equipment. And especially in industries as big as MRPL is, or any such industries, the downtime is a very, very important factor, because you cannot afford a shutdown of the process units, and even for a few hours, because that will hit the bottom line to a great extent, and the losses will be huge. So everybody would always try to see how to avoid these shutdowns, and these IoT-enabled sensors in these machineries, which otherwise would create these shutdowns of the process units, would be helpful, right? And these are all providing transforming systems in the process industries. Coming to the artificial intelligence and machine monitoring. So, you can settle down.
Quickly.
I hope all of you have come looking at TV outside about my speech. Thank you. So, coming to the artificial intelligence and machine learning, that's again a huge area of future growth, where, as I told you, they are going to make the machines predict themselves what is their health and what they are supposed to do, and they will tell us that please update me, please take care of maintenance of this myself. It will tell, the compressor can tell you that I am going to fail in the next 5 days. So please do something, please do some lubrication. Please change my bearings. Okay? Or the reactor can tell us that I am getting choked in the next 7 days. So please take action to ensure that it is not getting choked. Because a choke means a shutdown, and a shutdown means loss. So these things are becoming more and more practical now, using these AI and ML. So artificial intelligence and machine, in fact I can give an example of what we have done in MRPL for artificial intelligence and machine learning. We have few turbines operating parallelly to generate power, and as you all know, each machine will have its own efficiency and performance. So, and as a company, we would like to know which is the most efficient way of running a set of equipment. So we have put a AML package which takes all the parameters from these turbines, and it will tell us, okay, this machine is more efficient, this machine is less efficient, because each machine can be more efficient in some certain circumstances, when it is generating power or steam, condensing steam, or different methods of that. I will not get into that. So you can just imagine that there are machines which are efficient differently at different situations. So as a company, we would like to work all the machines at the highest efficiency. So these AIML packages will tell you that, okay, these are the machines you have to run. Okay, these ABC machines, out of these three, A, B only you have to run in this circumstances of the load and power requirement. And when the load and the power changes, you have to run A and C. Okay, these sort of decision making will come into picture with this AIML. And also with that, it will also tell us, of course, once you have this information, you can always calculate what is your benefit, what is the benefit to the company in terms of money. So the operator who is operating these machines will be given this information that, okay, if you are running A, B, C, A, B, you are saving X money. But if you are running A and C, you will save X plus money. So that money factor is also given information to the operator. So he can make it, he can realize, yes, otherwise the operator will not be knowing. It's a huge, complex, and for his duty, the main aim is he has to run. He should not, shut down any equipment. That is his first requirement. At the same time, he has to also know that, yes, if I run like this, I am making more money to the company. So these sort of decision making capabilities can come in using these AIML packages. So these AIML package will take the science or the physics of the equipment. The domain experts will also give their experience, and also based on the software and data collection. So all these three will be put in together and a package will be made. AIML is not just software. Okay, so AIML is having a software that is your data collection, calculating and coming out with some analytics. That is one part. But behind that, you need to have the domain expertise, which has to be built into the package. Then only you will come to know, as I said, what data you have to collect, what parameters you have to collect, and when that parameter comes, what is the meaning of that. So that is coming from the domain expert. And you are doing by collecting with the IoT sensors or anything, that is your collection part. Analysis is different. And coming to an interpretation of that analytical data is a third thing. That is a domain expertise. So all these things put together will give you the AIML package. So these are the just example of that, and this is applicable in all fields now. You can take any field in any process industry. Since I come from process, I'm telling you, everywhere this is required. Everywhere it is possible. You can apply AIML to improve your efficiency, to improve your savings, energy savings, etc. So, similarly in the maintenance of equipment. Maintenance of equipment means it's coming in all industries, where the machines, you collect the vibration parameters using the wireless sensors or wired sensors, whatever it is. Then you collect the temperatures, you collect the process data of that particular area, and then you will come up with this analysis and say, okay, this is what I'm going to do, and then next my vibrations are increasing, and my vibrations are increasing at some certain process conditions. So either you change the process conditions, maybe the process condition itself is an upset, may not be a problem with the machine itself. But all these informations can be analyzed and come to an interpretation and conclusion to say that yes, okay, this machine is going to fail, so let us take it into a standby mode, because normally in a process industry it is expected that there will be failures, and with one failure of equipment you can't shut down the entire plant. So generally you will have standbys. A pump A will have a pump B as a standby. So whenever you find a problem with pump A, you switch over, address this and come back. So this sort of thing will be possible using this AIML. And another area of growth is the drones. You know, the drones you must have seen in cricket matches or in your marriages where they take the photos and video and all those things. The drones have become so capable now that the most inaccessible places we can send them and find out the problem, issues. Like, I don't know how many of you have seen our MRPL. You will have huge tanks for storage of petrol, diesel and other products. So those tanks they have to be taken for maintenance to see what is the condition of the plates and other structures inside the tank. So this used to take months together. You know, you take the tank out of service, empty out the product, and then go inside. And going inside also is a risky job as well as a time-consuming job. So nowadays you can send a drone. You know, if you have to go inside, that has to be cleaned inside. The tank has to be cleaned to make it suitable for a human being to enter, because it's all hydrocarbons, and people have died going inside without proper breathing apparatus and things like that. So now drones can be sent. You don't need to be clean the entire tank to such an extent for a human being to enter. You can send the drones, find out the conditions, take the photos, and then come back, find out from the photos you can again apply your data analytics and see what should be the condition of this the tank. The tank means there will be plates, thick plates will be there at the bottom. So those plates will be seeing hydrocarbons, corrosive surfaces, so that it's expected that they start deteriorating. So corrosion will start, and then you will over time, once the thickness comes down, you will have to replace that. So when to replace that? Because it's not an easy job to replace. It costs you money, a lot of money, plus time. So you have to make a proper decision when to do that job. So these drones will help you in that. So drones also have become very powerful these days. Let's say a tall structure is there. So somebody going there, checking and coming down is a risky job again and time consuming. So now you use drones for that. If you see MRPL, you can see some flare going, fire, you know, being burned there. So that is a tip which is as big as this stage size. Okay, so you can't reach there and it's burning. So you will send a drone, fly close to it and see whether any problem is there in that, because there can be holes generated and things like that. So all these are just some examples of how drones can be used in the process industries. Or the line inspection, pipelines are running, thousands of kilometers of pipelines are running. How do you inspect them? How do you check their healthiness? It's manually impossible, humanly impossible to go and check everything. So you will send drones. You will send even I was talking to Indian Institute of Science, one drone expert. He was telling me now the underground line leakage also they are able to find. Okay, using drones. It's a developing field which is going to be there for future. Then, of course, robotics have become very indispensable in oil refining and distribution, where we can't have access physically. You can send a robot and clean the whole thing and come out. You know, especially I'm talking in terms of oil industry, because oil industry is something which is very hazardous and which requires utmost safety to be taken in any aspect that we do that. So robotics has helped us in doing all these jobs. So that's again in India, I think I have not seen much of robotics industry developing. There are in foreign countries, we have a lot of robotics industry developing. So that's one field which is going to be there for a long time. Then augmented reality. So these are some things which is for maintenance represents a revolutionary leap in industrial operations. You know, imagine a maintenance technician wearing a equipped technician equipped with the AR glasses or a tablet entering a complex industrial environment. So what they witness through their AR-enabled services, enabled devices, is not merely the physical machinery, you know, but a dynamic overview of the entire thing that is seeing as a person one is seeing. So this includes intricate diagrams, real-time sensor data, etc. So it will also give him a step-by-step instruction of how to do it, how to do a particular job. So it provides a fusion of both the worlds, physical and digital worlds. So this is augmented reality is really catching up, so which will be useful for many of our future engineers. And with all these things, environment is also getting affected. You know, the more industries are coming, obviously the energy requirement is increasing. The power plants have to come up. Then we have the emissions from all these industries. So environment responsibility is also very important, and instrumentation has a great contribution to make people environmentally responsible. All the instruments for measuring the environmental parameters have come up. In fact, in MRPL, we are mandated to measure the environment, conditions in and around the refinery. So we have placed different locations, continuous monitoring stations, environment monitoring station, and there are a lot of instruments which will measure the carbon emissions, the oxygen levels, the suspended solids, and as per the mandate statutory requirement, many parameters have to be measured, and they are all connected to the Central Pollution Control Board server directly, so that we don't play around with the readings, you know. So all these readings are directly going to the KSPCB, there's a Karnataka State Pollution Board as well as Central Pollution Board, wherein they can watch how the environment is there any issue because of the plant. So all this instrumentation is helping in the environmental management also. And going forward, environment is going to be a focus. So advanced instrumentation and control systems would be required for doing all these things, and avoiding and optimizing the energy consumption of all these things. All these industries are going to be energy dependent. So once it is there, then optimization of those energy will also come into picture. And once energy requirement is coming, pollution is has to be under control. Obviously, we get into the renewable energy sources. So renewable energy sources also is a field where a lot of instrumentation is going to be required, and it's a good field for future growth. And with all these networking issues coming up and all, cyber security obviously is one thing which is going to be there for future. Both the big data analytics and cyber security is going to be the field for us, because the data has to flow. Once the data has to flow from servers to server, the cyber security would be very important. So increasing digital technologies, including our process industries, I'm talking, that cyber security has to be. All of you must be aware of that Stuxnet virus which had created havoc. So there the virus can directly affect your PLCs. You know, it doesn't have to do anything else. They can directly affect your PLC controlling, let us say, a reactor. Okay, and create havoc like it did with that. So cyber security is something which is going to be very, very important, and it will be very important, crucial for safeguarding our energy infrastructure. So these are some of the important and future areas where there will be growth, and instrumentation technology and control technology will be very useful going forward. And I just wanted to speak a few words on the gap between what we read and study and what we see in the industries, because we get a lot of students we get a lot of students for some training and all. So that's very useful, I think, not only for students but also for the industry, because we would also get to know the young minds will give us some brilliant ideas when they are in the factory. They might be not knowing, but they'll be indicating to us some things which we would not be even thinking, because we have to be focused on one way of thinking. So that is useful for us also. So there has to be a continuous engagement between industry and so what are the things which we need to do? So the curriculum alignment, I am not sure how is that being done. How do we align the curriculum with respect to what is required for the industry? So maybe that has to be periodically reviewed and updated as and when we move forward, because things are changing fast and we need to be in line with that. So we may have to have more interactions so that periodically we can review, and I don't know how much time it takes for the syllabus to change in the
4 years.
Once in 4 years, okay. So, yeah, it's a good enough time for us to understand really what you want and then to change it. Then we can always, I don't know if you get industry experts regularly in the colleges to give, their viewpoints, their requirements as we go, and that would be good if you invite your industry professionals for a chat. And I don't know whether you have a setup. For example, when students come, there will be some lack of understanding about some of the basic things of instrumentation when they come. This is what we have observed. And if you have a whole setup, MIT may be having, if you have a whole setup of, let's say, a process itself in the campus, which has got all these measurements, all temperature measurement, flow measurement, temperature level, and a PLC. And how does a PLC work? A lot of students, when they come, they just see the PLC, note down some from the manual, and then go. That's a very initial stage of really. It's only a feeler, to just see, if you see the reports that they make, it's all superficial. When they really have to, what they really have to understand is how the PLC works, why it works, and how the logics are built, how the interlocks are built in the process industries, why it is built. Let us say they are using a mass flow meter. They read about mass flow meters. I think most of you must have read a mass flow meter, about a Coriolis mass flow meter or something. So when you go to the process as an intern or something, you should know why it is being used. You should ask why it is being used. A mass flow itself is being used, why? Why not other type of mass flow meters? So for that you need to understand what is the process. So for instrumentation engineer, understanding process is a mandatory thing. Then only he or she will be able to tell why that measurement is required, why that sort of principle is used in that measurement. So when you go to the industries or when you see the process industry, you should ask yourself why mass flow meter is used there, why not orifice flow meter is, So these sort of questions you should ask when you go to the industries, and then even if you understand a small section of that plant, it is good enough, because it is going to repeat in other places. You don't have to understand the entire refinery, for example. When you come to a refinery, you don't have to understand the entire refinery. But you should understand one part of your instrumentation, how it is applied, why it is applied, and once you understand the process, you yourself will know why it is required. If the process requires accuracy of, let us say, 0.1%, that's why that instrument may be there. Why 0.1%? Because you should know what is the process. Okay. So I just would like to tell you all that you should think in those lines when you visit any process industry. And how do you, as I was talking about the whole system of measurement in your lab itself, which can be used for all future classes. Full setup of a process, with a pump, with a small reactor vessel, and temperature pressure measurement, which is connected to a PLC. You get PLCs, it's not a very costly thing now, for academic purpose, where you can show the people, the students that, okay, this is how measurement does, this is how the interlocks work, okay, and you can join with the chemical branch also, so that they can also know, and you can give it as a project yourself for your own students to build that plant. So these are some of the things which will definitely help for the students when they come to the field. They will really be knowing exactly what is required in the process industry. And because I was since I was told to come here, I was asking our engineers to give me a statistics as to what the students learn when they come to our internship, and what are they interested in, or what is their knowledge which is good and what is their knowledge which is lacking when they come to these roles. So they have given some areas where the knowledge needs improvement, and there are places where they are good also, like what is a control system, what is the feedback control, all these things they are very clear. But what is a document which is used in the instrumentation process industry? In the process industry, what type of instrumentation documents are used, like PFDs, PIDs, knowledge about that, little bit of knowledge when it comes in the college itself, it would be useful for them when they go into the field to really understand, because as an instrument engineer, when he goes to the college, when he goes to the industry, the first thing will be given to him is a paint ID. He has to refer the paint ID. So if he doesn't know what is a paint ID and what is the different components in that paint ID, he will be struggling. So if he has that background a little bit beforehand, so it will be easy for him to take off from there. And similarly on some of the field instrumentation has changed a lot now. It has taken a leaps and bounds of change in terms of technology. So those things, maybe from the manufacturer side, if we can get some presentations on the different technologies of instruments that is coming up in future or in vogue, that would be preparing the students better when they go into the industry. This is what my feeling. And obviously there would be something on the safety instrumentation also, I think. Safety instrumentation plays a big role for the safety of any process industry, whether it is a chemical industry or a petrochemical or any industry where safety is important. Instrumentation plays a very important role, because that is the one layer of, there will be several layers of safety built in a process industry, not just the instrumentation. There will be several layers of safety built in. The safety starts building in the design stage itself. How do we design the equipment? How do we design control systems, control loops? The safety is built in that itself. design the pipeline structure. So safety is already built in them. So there are 7 layers of safety are normally built in any process industry. Instrumentation is one of them. So little bit of knowledge on safety layers would also be useful when they get into the process industries. So I think I've covered sort of things that I wanted to tell you all. I hope it has been useful for you all, and I thank the organizers for inviting me here and helping me to share my views on what goes on in the industry, and all the best to all of you. And I'm sure MIT, being a very well-known the college in the engineering, has a lot of people who have made good names in the world. So all of you should reach that level, and all the best to you. And whenever you want some information or knowledge or something you want to learn from for instrumentation in MRPL, you're all welcome to contact us. We'll be glad to help you to understand whatever is possible from our side. Thank you, and thank you for the organizers. Thank you.
I thank Mr. Satyanarayan HC from MRPL Mangalore for sharing freely of his time and his experience and motivating our students. If there are any questions from the audience, you can ask now. Any questions? Any questions from the students?
Either they have understood everything or they have not understood anything.
It's an opportunity for you to ask. You are studying something in the class, there is some gap, or if you don't know why you are studying, just ask. What is the relevance of what you are being taught? Many things he has told which is very much there is already told. Some of them you have to include. There is a gap, we can ask.
Of course, I can. When we gave the introduction, you might not have seen instrumentation at all in my profile there. I think I've worked for a long time in instrumentation. Of course, as I've spent 33 years of experience, I would be definitely moving into management side. So I have moved into other areas also, like production planning or process engineering, in fact, and international trade and marketing and all those things. But the basics of what you learn as an instrument engineer, not instrument, as an instrument engineer, would be very useful and a very interesting thing to do in instrumentation. So all of you are quite fortunate to have selected instrumentation. And since you don't have any questions, I think it's good that you are all good instrumentation engineers. Yeah, please.
So actually, today we talk about digital twin. I've seen many industries creating the digital twin for.
Today is what we have seen is the digital twin era, and even I have seen some examples earlier. Many industries are creating the digital twin. So I believe the refinery is something which is very critical operation, and you must be also doing or exercising or try to create a digital twin for your process. So any thought on this?
Yeah. Good point there, which I missed in fact to tell this about the word digital twins. What the turbines that I explained to you using AI, ML and all, that's basically a digital twin we have done. We have built the twin of the existing turbines, and they calculate and find out that how the equipment has to work, and that is the whole turbine the model, that the turbine is built in the equations basically, and those twins are working behind, and they are telling the operator that you should operate the plant like this, operate the equipment like this, and it gets updated as it's an equation, it's a software basically. So it needs to update itself. So that's what the artificial intelligence does. It takes the data and it keeps on updating the model itself and making itself better to predict how the machine should work. It can be based on the conditions, that process conditions are there. It will be working behind the scene and telling the operator basically. So that's the digital team we have done, and we have done quite a few. We have done for a reactor also, where it's a polypropylene reactor, which helps us in telling that if there is any choking that's going to happen, it's working behind, and also to optimize the plant, because the manual operation or even the DCS operation has its own limitations. Because DCS operation will be like manual operation was in minutes or hours. DCS has made it in seconds. The measurement will be in seconds and action will be in seconds. But there is something more, even as you go in between milliseconds and in further lower down, it will not be possible by DCS. So we have the optimizers built in using AML, which finds out what is the optimum position for, let us say, there are 10 flows and 10 outlet flows and 10 inlet flows. So you have to control these two to optimize the plant. So the digital twin will calculate which are the flows you have to optimize and which are the flows you have to control outlet. So these things are built using the digital twin. We have done that, yes. And digital twins are going to be there in future. These are all the products of AML.
Good morning, sir. Firstly, thank you for the wonderful talk, sir. My question is, sir, you mentioned that students come for training in MRPL. So what all aspects of instrumentation are they taught? Like, are they taught from the basics and then we go advanced? And how long are they taught for?
The students, when they come, I think they come for 6 weeks or 2 months sort of program. So, as you know, the training is not our core business. So that's a secondary part for us. So obviously, we have a set of programs made as a standard program we have made, so that they see the manuals on half a day and then go and see the plant in the second half of that particular plant. So when this is some program we have made, but the interest of the student will take us even further. And if the student comes and asks that I am seeing this flow meter, it is looking different from this flow meter, what is the difference? If somebody comes and asks, so then we'll be able to explain to you, yeah, this is the difference and why it is there and all those things. So a lot of things depends on the student. So we have the facility, we have a set of program we have made for each batch of students. They will follow that. But then what I feel is that when we give a manual, for example, and they go through that manual, you should start asking questions. We don't see people asking questions, because we don't know what you have understood, what we are making. The program will tell you a brief about the process, about the plant, about refinery, about MRPL and all those things. But then going further into that, we would not be able to know, because if you come and ask us, then we will be able to explain. So that's why I said, if you have some background of what a PNID is there, PFD is there, then when you come there, you can see and then say, okay, this is, what is this? I am seeing this thing in PNID, but what is there? Where is that in? So some sort of question. So we are open for any questions, but questions should be asked.
So maybe that is Sir's way to say, yeah.
Because before that, don't think any question is a stupid question. Questions are not stupid at all. Answers can be stupid, but questions can never be stupid. So You don't have to worry about asking anything and everything to anybody in your life also.
Good morning, sir. As you mentioned that as the factories and processes are moving towards enabling, like becoming IoT enabled and becoming network centric, cybersecurity starting to play an important role. So one of the best ways to be cyber secure is to have regular updates over your network and over your firmware. But that comes with a certain amount of downtime, and also updates can go wrong and it can result in a even greater downtime. So as a process manager in a plant, how would you do the risk to benefit analysis for that? Like if you know that you have to apply a certain security update, but there's a chance that it can go wrong and it can result in an indefinite amount of downtime for the plant. So how will you do the risk to benefit analysis for that?
Yeah, good question. Because the downtime is something which we want to avoid as a company. So we'd always build in some security in that. Like as you said, as I told you, there will be always a standby for equipment. So if there is a problem with one equipment, we'll change over to the other equipment. Similarly, in DCS or in any electronic systems that we have, redundancy is built everywhere, right up to the finest. Sometimes if it is so critical, then even we build a redundancy in the valve itself, the control valve itself, in the solenoid valves itself. Solenoid valve is something which operates the control valve on off. So there also we build a redundancy. And some places where the process is so hazardous or so critical, we build a triple redundancy. There will be 3 instruments in the field, 3 valves. And when the cable comes to the control room, there will be 3 electronic cards, separate PLCs. Okay, all this safety will be built in depending on what sort of downtime you can afford. So cybersecurity is something, so we build even in the, so DCS is at the lower level. So then there is a network before that which connects all the systems, and there is something called intranet which is within the company which is connected to the outside world. So if somebody has to come through that, so we have to build some redundancy in those networks everywhere. So those sort of redundancies are built everywhere. But cyber security, people keep on improving themselves also to break it, but we also have to keep on doing it. That's why cyber security is something which will remain always. It's a field which is always going to be there. People will be building new things, you will be countering that, so you will be building, they will be building other new things, after all it's software. Redundancies are built wherever it's very critical.
Sir, an immense amount of natural gas is flared off by refineries across the globe every year. Are there issues with the scale or the economics as to why flared gas recovery systems aren't widely adopted? And if possible, how could AI possibly help this?
We don't flare just like that. It's like the flare that you see in MRPL, it's a safety measure actually. So we would be keeping that flare burning, that flame burning in a very small way, just to ensure that in case of emergency, the whole plant is evacuated with the gases and the hydrocarbons, so that the plant becomes safety and you burn off. You might have seen many places where there's a fire in the tank or anything, they just don't do anything, just allow them to burn, right? So the similar thing here, that we keep that flame burning only to ensure that in a case of emergency, we have the flare ready and it's all connected to the emergency systems, and entire unit will be evacuated from with the hydrocarbon. So that's the flaring that you see. Otherwise, it's a loss of money. You're wasting your money buying crude and making of gas or oil and then flaring. It's just burning your dollars. So nobody wants that, but it's a safety measure that we keep burning that. Yeah.
So there was a mention of Industry 4.0, and I just want to know how MRPL is adapting into Industry 4.0 because it's a very hazardous environment, and what kind of safety measures are being employed, and the scope of, say, AI operating the entire factory, because you're practically talking about no human intervention there.
See, Industry 4.0 starts with your IoT sensors and all. So basically, all the information is brought into the system with these sensors. Let us say, earlier we used to have only temperature sensors or pressure sensors. Now you have the thickness sensors, corrosion monitors, like in a control pipeline, what is the corrosion happening. So these are the things which are connected to the system. And that is what is IoT basically. And then the operations are done at the DCS level, and above that is the AIML. So if somebody builds in a model to operate the plant, it will be through DCS only. So the safety is built in.
So I think there was a class that they are getting to. Do we have time for one more question?
Right, sir. So far, we've seen in the industry about consolidation of these systems and processes, right? Running them, and we've seen these systems more and more that you require less personnel to run entire factories, right? Due to the consolidation of these systems. So, setting aside the installation and construction of these control systems, do you think this has raised or lowered the bar of qualification to work in these industries in general, because of how easy it is or how hard it is to run these systems?
No, the skill set has changed. The skill, as the technology changes, the skill set has to change. You have to reskill, upskill, undo your skills. All sort of things has to happen as the technology changes. So it's a question of skill sets basically, and not the. See, the number of people earlier, people saying automation is removing the jobs or something like that. It doesn't happen because only the skill sets are changing. The required skill people have to come. So, I hope I answered you what you wanted, or anything else? Yeah, please tell.
Sir, I meant more in the sense that when you're, say, hiring someone to maintain these systems or run them during operation, right? Now that these systems have so much self-maintenance, right? When you're looking to hire people to run these systems, are you looking for a higher bar of qualification than previous years in the industry?
You cannot say higher qualification. The skills are changing. That's what I'm trying to say.
Right.
See, earlier maybe you wanted somebody to open a valve or close a valve. Okay, so he would have required some skill. But whereas now you may have a system to operate that. So you want somebody who can operate that. So the skill set has changed.
Right, sir.
So that's what I'm trying to say. The skill sets have to be changed. Or somebody who is already there, he cannot be removed. So his skill has to be upgraded.
Right.
Thank you so much, sir, for patiently answering the questions from the students. We encourage you to continue to interact with our chief guest during the short tea break that we will have now. We'll regroup at 11:45 for the next keynote address. I request our HOD to hand over a certificate to our chief guest as a token of our appreciation.
Thank you for patient hearing.
I thank Mr. Satyanarayana FC for giving an overview of what is the requirement of instrumentation control engineers, electronic instrumentation engineers, and the skill sets expected when you go for the industry. Regarding our curriculum, we will take him to the department, laboratories, and brief him about what is there. Having PLC labs, automation labs, DCS, SCADA, and process control instrumentation theory is there. I think some aspect of PID diagrams are being taught to our students as well. So it is earlier our program was instrumentation and control, and now we have made it electronics and instrumentation. So in spite of that, what was being thought in the initial part of instrumental control is also being catered into. And we revise our curriculum once in 4 years, and yearly you have 2 DCC meetings wherein we fine-tune that curriculum based on the expertise. And our DCC and viewers has got industry experts as well. You take part, you take alumni, industry experts, and the students also in the curriculum division. This is the process we are following, and definitely we will take more input from you as you are nearby. Until now, we are using people from some companies like Honeywell and other companies in the curriculum committee meeting. So it is easy, and many times they are not able to come because of the distance and the time of travel. We will explore nearby industries like MRPL, expertise also in our country. So you have given a lot of insight into our students about the requirements and skill set required by the students. It's very good talk, informative talks. I thank you for taking your time and giving us good insight into industrial instrumentation requirement. Thank you. Short tea break now.
We'll reassemble at 11:45.
Yeah, so good morning everyone. So welcome back. So next now we have a brief talk by Mr. Santosh Gosavi from Tata Motors Pune, and he will be giving a keynote lecture on digital transformation journey in automobile industry. So I welcome you, sir, and you can start the keynote session.
So good morning, friends. Good morning, sir. So I was waiting for response. Okay. So we had a tea, we had snacks. So where is the energy? Good morning. Good morning, sir. That's nice. Okay. Thank you. So let me introduce myself. I am Santosh Gosavi. I'm basically from the field of automobile engineering. 25 plus years of experience in automotive, Tata Motors, working in engineering research centers at Pune. Let me tell you my experience so far, like 25 years back, if I go back. That time, the automobile engineering or industry was mainly dominated by mechanical engineers and automobile engineers, and up to some extent metallurgy. When I joined 1998, so few of us electrical electronics engineers. So that time the Tata Motor was developing Indica, the first indigenous car. And they are looking for, because getting some electronics in car, that's what the plan. And wanted to have some electrical electronics engineers. That's how I got into the Tata Motors. Today's scene in Tata Motors. Majority recruits are electrical, electronics, instrumentation, control engineering. Majority. And industry need them. High demand today. That's the shift we have seen. Moving from mechanical automobile to electrical electronics and instrumentation and control systems. Next decade, computer engineering and software. developers. That's how industry is moving. So I may not able to give you the full overview at the time of maybe 40-45 minutes or 1 hour, but I'll try to give you some aspect or highlights on the automobile engineering and what kind of technology, the digital transformation today we are going through. So this is outline, I'll quickly cover. The buzzword says, that's a bullet point number 4. That's governing industry today. SACE is connected, electrification, shared, and safe mobility. That's how it's governed today. Future will be software defined vehicles. We'll deep dive in understanding the advanced driver assistance systems and autonomous vehicle. Then we'll have question answer. Otherwise, I'm also okay to have the questions on the spot, on the slide, while I'm going through to make it interactive. That's also fine. So not necessary that you have to wait for end of the presentation and ask questions. On the way also, please raise your hand, whomsoever has a question, and I'll try to answer to my capacity. Now, car industry really, if you look at this picture, this goes long back. Before invention of steam engine and the internal combustion engine by Carl Benz in 19th century, earlier days, the cars used to be pulled by horses. Like there was a term, horse car or horse wagons were used earlier when engines were not there. So let me tell you a story there. So there was a typical problem with the horses. Horses used to generate a lot of quantum of solid waste. In the city of London alone, about 20,000 kg of manure used to get scattered on the road. So rate of generation was so high than rate of clearing it out of the road. And that has created a lot of problem, the hygienic problem. And created starting basically threatening kind of thing to the human life. So we know whenever there is such challenge to the environment, to the human beings, the engineers cope up. Engineers come forward and solve that problem. So this was the problem in 19th century. How to avoid using horse for pulling a car or wagon. That's how all engineers started working and then come up with steam engine. In 18th century, the Nicolas Joseph Cugnot from France, who developed the first car on steam engine. Of course, the speed was less, it was very bulky, problems were there, yes. So did not survive long. Later in 19th century, Carl Benz of Germany, he actually made a revolution and he came up with first internal combustion engine. And that's how basically we can say that in real term, the automobile kicked off from there. Today we see electric cars on the road. Is it new, electric car? We see today, but it's not new. 19th century itself, electric cars were present. Of course, they did not survive that time because the electricity itself was a problem that time. But engineers made the car, electric car, that time in 19th century. So that's how the first wave of revolution in automobile industry took place in 19th century. Now we are in 21st century. Evolution is taking place again. What are the drivers today? The drivers today are mainly the sustainability and environment. It's pushing us. Safe mobility solutions, the digital transformation pushing us. So what I mean by environment and sustainability. Now we all know cars emit a gas. So there is a constraint, like we have the regulation in place. Now we call it the BS6, the Bharat Stage 6, with the emission norm. There's a CAFE norm, corporate fuel economy, which is mandating automobile corporates to reduce the emission, not only the tailpipe emission, but the factory emissions as well. And the digital transformation which is taking place today in automobile industry is making highly connected and autonomous. Now, if you really look at this slide, the renowned futurist Gerd Leonhard is a German futurist, technology futurist person. He commented about this. Technology is exponentially growing. But humans cannot think exponentially. Humans are naturally trained to think in linear fashion. So technology is overcoming us. That's what we call artificial intelligence. It is basically overtaking the human brain. So what advice he is giving, don't try to compete with machines. Instead, focus on doing the things that are inherently human. Very nice, he's saying. And that the machines cannot copy. Like being creative. Humans are more creative than any machine today. And be empathetic. So these are the two unique things the humans should pursue and should build upon this. This is another example to talk about digital transformation. Now this is a example like the Michigan Lake here. Basically, if you see the Michigan Lake and it fills up with the water. What it tried to say, illustrates is that to understand how exponential growth can be misleading, slow at first, but then suddenly explodes. See the simulation of filling a Lake Michigan with the water using an exponential curve. So this is used to illustrate how computers can achieve the same computational power of the human brain following Moore's law of doubling computational power capacity after every 18 months. So if you notice, it starts with a blue dot at the south pole of the lake, and then there is a scale on this side. So in last 3-4 years, the exponential growth is happening. So this illustrates how the technology is disturbing not only automobile industry, everywhere, all industries. It's you and me, it's human life, disturbing that. And we are all affected. But nothing to worry about this. So we have to accept this, work with this technology, master the technology, and build upon this. Now let's come to the domain of automobile. Now vehicle electronics today, if you really look at everything, lot of sensors, lot of control systems. Then you have the vehicle networks in place and actuators. That's how the automobile is. But remaining all steel structure. Everything otherwise electronics inside today. So, if I have to share the example of my own example in Tata Motors, 25 years ago, Indica, the first indigenous car, had no ECU, no control system. Had only, because it was a BS3, and had only electrical, some horn, lighting systems, window regulators, wipers, some electromechanical systems, I can say. Now today, Nexon EV launched 2 weeks back. At 25 plus ECUs, 100 plus sensors, 40 plus actuators. That's how in 25 years, Tata Motor, I'm saying. But if you go BMW, Jaguar Land Rover, Mercedes, which is high class vehicles costing 4 crores and above, class of vehicles, 70 plus ECUs, modern vehicles use. 200, 300 sensors are in place. Actuators are in place, so many things. So that's how the shifting has happened. We are moving from electromechanical domain to electrical, electronics, control, instruments, and future is something else. So I said about this buzzing word in the industry, in automobile industry, the CIS. So connected car, what does a connected car means? So the main motivation of the connected car is to enhance the driving experience and improve the traffic management. It involves real-time data collection and analytics to enable seamless connectivity to provide digital experience to the consumers. So I will see the examples in further slides. Electrification, all we know, to have a more cleaner and more sustainable transport solution, the electrification is happening. Now, shared mobility is something we all use, Uber, Ola, right? So that's a kind of shared mobility where the connected feature of the car is being used, and so shared mobility is something coming out of that. Safe is not only the structural safety, because safety, when we call it as, there are 2 levels of safety generally we say in the automobile industry. One is the passive safety, another is the active safety. So passive safety is something once crash takes place, when collision happens, injury should be minimum, deflection should be less. So what is required to protect the passenger in the compartment, the structural design of the car, the inflation of airbags placed at various corners, these are a part of passive safety. Because this is something inactive, like after crash takes place, what are the measures you have in the car? Those are passive safety. Now more towards active safety today. Active safety is basically, the basic example is the ABS braking system today we have. Electronic stability programs in the car. The car should be stable, it should brake, it should not skid. These are the basic elementary level of active safety. Moving towards is more towards the autonomous and driver assistance systems. Okay? So we'll see more about this in the further slides. Now let's talk about what is connected car. Now on the picture you see everything is like, so many things are there. Some multimedia, then infotainment system of the car, keyless entry, internet access. So connected part is basically the Internet of Things, meaning everyday items being connected to the internet. That's what definition we know. But what is the intention? To make the driver's life, passenger's life easy, give them more comfort, very digital experience, and ease of driving. That's the motivation. Now, the General Motor was the first automaker to deliver a connected car in 1996. they call it as a OnStar, they marketed it as a connected technology. Now the connected car has its own connection with the internet, usually wireless local networks that allows car to share the internet access and data with other devices inside and outside the car. Now let's look at what are the examples we have. Now today we use navigation system very comfortably, right? Life has become easy. So that is one of the feature where the traffic monitoring can alert you, boss, there's a traffic ahead, please take a diversion. So that's a connected feature. Then we have the mobile connected features, like if my car is being soaked in a summer, hot outside 45 degrees Celsius, and I wanted to travel, so while getting out of my office or from home, on the mobile I can start the engine and put on the AC. So before I get into the car, it should be comfortable to drive. And there's so many features are there after connected. Then, which is something safety related, like e-call, like emergency call and breakdown calls. Those are the feature of connected. Like, for example, you unfortunately meet with accident. Then your car can call a nearest ambulance, nearest police station, nearest hospital. No need to make manual call. It senses the pulse, crash, yes, crash has taken place. It makes a call on its own. And you get an aid immediately. There's a breakdown call, like if you driving and then you got stuck somewhere on the midway somewhere, what to do? So there is a provision for breakdown call. So you just press the switch, it goes to the service center, somebody will help you out. So by 2025 you really look at all cars will be connected car. Today almost most of the cars are connected, but still it will become such a basic need. So all in another 3-4 years, all cars will be connected cars. Now in connected car, not necessarily everything has to be through cellular phone or through cell network. Now there are different communication protocols being used in automobile. One is a direct vehicle communication, like they don't use much cell network, but they use some other protocol that. So it is based upon the intelligent transport system, a 5.9 gigahertz spectrum, which is reserved for vehicle direct communication. And it doesn't depend upon cellular network. Network hai ya nahi hai, still it works. So there are, like for example, vehicle to vehicle communication. Vehicle communicates with adjacent vehicles and communicates what is my speed. It gives a warning. It gives to avoid collisions. Then share the traffic information with among them. The other example is vehicle to infrastructure communication, where vehicle communicates with nearby infrastructure. For example, if traffic light is becoming red, then the traffic light will tell boss, car, please reduce your slow down, I am becoming red. So that's how the technology is going. The another is vehicle to pedestrian. Where in vehicle to pedestrian, vehicle communicates with devices carried by the pedestrian to ensure their safety. For instance, they might warn a vehicle that pedestrian is on the walkway ahead. So that kind of possibilities are there in the connected car. All we know 5G, and of course we started in India is already being used now 5G. Though it's not so popular, but becoming now picking up very rapidly. So it will probably change our behavior also. So, and it is most reliable way of communication. And mostly it is going to help in making the vehicle more automatic, more automation, and more safe. The most important aspect here, like over-the-air update, which is today probably not so much being used, but once the 5G becomes a daily life, then this will help to update any patch, any software on the car. Not necessary that we have to take the car to the service center or dealer and get a new feature updated or software updated. So it can happen remotely. Second is data monetization. Now how the data monetization is helped? For example, like now the insurance company generally, they issue a insurance and we generally pay a premium. Now today everyone like you, me, whomsoever it is, depending upon the value of the car, we call it as depreciation value of the car. We pay the insurance, they charge the insurance premium, they will charge, and then we pay and we get insurance. But in advanced countries where it's not the only way, insurance company buy your data from the OEMs. If I'm rash driving, I'm not driving good, my driving habit is not good, then the person is very calm driving. So the premium charged by insurance company to me much higher than the other person who is driving calm, cool. And that's how the data monetization is going to happen. And second is about, because the car is becoming a plant, this kind of plant itself, lot of sensors are there. So the health monitoring of the car. So there are so many things are there which we generally pay attention. Is my engine level is okay, whether engine oil is good, transmission oil is good, whether my brake is on, my clutch is on. So many things are there. So we need not to worry about it. Everything is being monitored and will be monitored, and it will predict, it will tell you. Please, now it's high time, please replace your brakes. Something like that. Now, this doesn't happen automatically, so what is behind it? So, they have seen, okay, sensors are there, everything is in place. But how does it happen? So, there is a backbone structure for this. So, these are the all sensors we spoke about, actuators and the ECUs, on-board ECUs on the car, correct? Now, there is a connectivity network layer here. Now this layer is a basically, of course, there is a first in-vehicle network here also, so they are connected together, and there is a cellular network or connectivity network. It can be wireless, as I said, direct communication, independent of cellular, or there is a cellular or satellite communication. Now, okay, now what to do? Communicate means what? So data has to be exchanged. That's what communication. Now there are some OEM cloud. Now Tata Motor has a connected vehicle platform cloud. So all data, so my car is connected. How I am driving, where I am going, how many times I am accelerating, how many times I am braking, in which gear I am shifting, at what speed I am driving. All data is being monitored, is going to the OEM cloud. So some information goes to OEM cloud and some data goes to the common cloud. Common cloud means an open source cloud kind of thing. Now what are the applications? Okay, data is coming. What next? Now applications are like a product optimization. So first application, what product means, like the OEMs now analyzing customer preferences through this data. How they drive, what they need, what features they are looking for, so many things. So it helps, it goes back into the R&D. So it's a continuous monitoring of customer behavior, driver behavior, and get a meaning out of it. for developing the new products. Second, maintenance and service, as I said, predictive maintenance. Give warning, something oil change, brake pad wear, anything, give warning. Then there are some end user services, like where is the next charging station for me nearby, so it will pop up on the screen. Boss, your charging is low. You will be running out of fuel, you will be running out of storage, battery capacity, please SOH. 2 kilometers away there is a charging station, please charge yourself. So that kind of popping will happen. Car sharing, of course, as I said, Ola and Uber and so many things, route automatic, so many things, though they use that information. And the carpooling, there's one app, the carpooling apps, like it's not Ola and Uber, but it's being run by, not the business ones, as will say, but just to help the productivity and efficiency of transport system. The people can register, like you can register with that organization. If you are driving from one location to other location, then you can, somebody can accompany, you can give the pick up and drop facility, free of cost, of course. It's like there's no business involved here. So that kind of structure are in place. Now next decade is more towards the software defined vehicle. Now take an example of telephone, cell phone, probably. So those were earlier all mechanical devices, landline devices for calling only. To go electrical hardware centric, first cell phone 1990s, where we could text and play some games. That's all the basic telephone or cell phone. Now today's software defined smartphone made our life digitized, everything. We can call, we can message, we can chat, video streaming, social media, banking, anything we can do cell phone. Laptop is not required. Same thing is happening in watches also and some other industries. So automobile is not away from this trend. So that's how it's going to happen. More or less, the vehicles will be software defined. So what is software defined? So software defined vehicle is a term that describes a vehicle whose features and functions are primarily enabled through software. The result of ongoing transformation of the automobile from product to product that mainly hardware based to the software centric electric device on the wheels. So the software defined vehicles will have ability to upgrade your car feature. Now for example, let me tell you. Now so what's happening today, because the cost of hardware is not drastically increasing. So how to differentiate between car A and car B? The hardware is more or less same, but here the software comes in. So now the business would be, if you wanted to have some feature like ADAS feature or emergency braking feature, or you wanted to lane keep assist feature, or any feature like subscription based, you have to pay as per the subscription based. Hardware is there in the car A and car B, but car A may not have software defined vehicle, but car B is a software defined vehicle where on the air you pay a subscription fee, your feature is enabled in the car next day or on the same day. It's like an app on the mobile app. That's how it's going to happen. Now Tesla Model S, which is an electric vehicle, has this feature, like the customer can pay the subscription charges and get the required features. That's how it's going to happen, like autopilot, smart summon, sentry mode, dog mode, so many things are there. The other car, Neo, which is a startup company as such, Neo, like an electric vehicle manufacturer. So they have, like, if you want assistant, like driving assistant or chatting assistant. So many assistant features they are offering in the car. So everything is subscription based. So that's a new business model coming out. Now let's look at in-vehicle network. Now, earlier days, you must have heard about CAN, the Control Area Network, which is a backbone so far for the automobile in-vehicle communication. Because sensors, actuators, and ECUs has to connect, transfer data, handshake, communicate. That's how today the backbone is, the Control Area Network. But as number of sensors are increasing, the traffic is increasing, so bandwidth is not sufficient today, CAN bandwidth. Hence, it is moving towards the CAN FD, the flex ray. There is another protocol that is a media-oriented system transport, we call it MOST. So that is particularly fine-tuned only for infotainment system in the car. So depending upon the need of the system, of subsystem of the car, the network model is being used. And there's all these network models, the CAN in the one corner, the MOST in the other corner, and particularly autonomous vehicles coming out where the data itself is probably, if you drive a car for 8 hours, 1 TB of data will be generated in the car. It's huge data today, 1 TB of car. How it has to be handled? So there is only way use Ethernet in the car. That Ethernet speed is 1 Gbps to 50 Gbps speed. That is the only way. There is no other way. So that kind of architecture changes are happening. And that is going to govern the future. Now let's look at about the electrification of automobiles. So in between, if you have any question, please raise the hand, no issues. So let's talk about electrification. Now, fundamental and key objective of electrification is to replace the gasoline drive with the electric powertrain. Now, why it is actually? So, as we know, the typical internal combustion engine, which gasoline engine, diesel engine, what we see, that is efficiency is very low of converting the fuel energy, chemical energy into the mechanical energy. The efficiency is about only 17 to 20%. That's how. Other remaining energy is waste. But that is not the case in electrical vehicles. In almost 85-90% there is efficiency. So that's how it is booming up and helping, and that's the advantage. So as we know, the battery basically powers the electronic motor through power converters, and during braking it generates the energy, and again regeneration braking, called it regenerative braking, and generates the energy and feeds back to the battery. Now there are different motors are being used, like brushless DC motors. Mainly these are being used in 2-wheelers and 3-wheelers, brushless DC motors. Then permanent magnet synchronous motor. These are many EV manufacturers use for high performance motorcycles, electric motorcycles, and in few electric cars as well, and electric buses. Another is a AC induction motors. These are again 2-wheeler and 4-wheeler. Some manufacturers use, but mainly it is a permanent magnet switch reluctance motors. These are the coming out very good in terms of efficiency of working and getting the best out of the EVs, and that is being more used nowadays in our passenger cars particularly. Now what are the types of electrification? So we know our battery electric vehicle, that is one. Like there is no other power source. It's only battery, and battery feeds a motor, and motor drives the mechanical gear train, and that's how vehicle propels. Other is a hybrid electric vehicle. So we have seen some of the in India also hybrid cars are available. No, hybrid car is a combination of ICE engine, like typical conventional powertrain, and electric powertrain together. And electric powertrain use need base. Generally, it is driven by ICE vehicle only, ICE powertrain only. But in case of, for example, there is sudden requirement in the torque, like you are standing on the signal and you want to accelerate. If you suddenly accelerate, electric motor comes in and supports that. So when there is high demand, electric propulsion system comes in place and it supports the ICE engine, so that efficiency is improved and get a fuel economy out of it. Plug-in hybrid is something mix of both. You have both option. You have the electrical drive, you have the mechanical drive, and mainly like it's like a battery. It's a combination of conventional powertrain and electric powertrain together. And plug-in you can charge also. So that's a plug-in hybrid. So at a time, it probably starts with electric drive, and once your battery depletes, it automatically switches over back to the mechanical drive or ICE engine. Fuel cell vehicle. No, fuel cell is basically it's the new. Actually, lots of hopes are there from hydrogen as an energy, and lot of research is going in hydrogen energy today. If you look at Reliance, huge investment they are making in understanding the hydrogen energy. So that's the future people are talking. So diesel cars will go, petrol cars will go, EVs will sustain for some time, but particularly if you look at the big trucks, the bigger application, like if you see bigger trucks moving on highways, electric drive is today is not really economical, and it's not working equation for electric drives, but hydrogen has a future there. So fuel cell vehicle is like that, like hydrogen energy is used to convert electricity, and that electricity is used to charging the batteries, and then battery drive the, as we know, the battery drive system, battery vehicles. The another technology on H2 is like we use CNG in combustion engine. Lot of research is going using hydrogen in the combustion engine. So hydrogen, we know it's a bomb kind of thing. If you keep it, store it, it's like a bomb. Earlier days we heard hydrogen bomb, so it's nothing but a bomb. Anything can happen. And hydrogen is something, if it leaks, not possible to sense, detect, see, smell, impossible. Anything can happen. You can realize after happening something only. Oh, sorry, it leaked and something has happened. But a lot of, because it's a zero emission fuel. There is no emission, absolutely, from hydrogen combustion. So that's how the technology is going towards, and is also putting a lot of challenges. Now let's look at electric vehicle again, coming back. So this is what general architect of electric vehicle we see. Lot of power electronics, basically. And many countries have already said they will stop manufacturing ICE. So India said 2030 on cars, passenger cars, not trucks, passenger cars. And this is what governed by the protocol which our Honorable Prime Minister has signed. So power conversion system are essentially important to modern use actually. So all this basically to handle this highest power, high voltages, these are all governed by power MOSFETs and insulated gate bipolar transistor IGBTs to boost efficiency and minimize the losses in the system. Now, of course, the power MOSFETs are limited to operate high voltages, because now what voltages we are talking in electric vehicle is 600 volts today. Tomorrow it's 800 volts. So that's what the today's scenario we can see, up to 800 volts DC volt. And IGBTs are good in power lifters. Right? They can work up to 1600 volts. But then they are not good in high frequency switching operation. So it's a balance between, like because the converters work at about 200 kilohertz switching frequencies. And so that is the reason the conventional silicon and germanium semiconductors are not good in handling the high voltages as well as higher switching frequencies. Hence now silicon carbide and gallium nitride semiconductors, which is wide gap, which is bad gap, no? Wide gap devices can operate high voltages and high frequencies. So that's what taking place now. That's what the semiconductor industry changing now. Now, why battery electric? We have a lot of heard battery electric vehicles, a lot of issues and some concerns and apprehensions we have. So these are the typical apprehensions like cost. What is this? So cost is high, premium charges are high, driving range is there, lack of EV infrastructure. But then point is basically, these are the things, concerns are there in through survey being done in 2018. But of course, then these are the things as an engineer, these are the challenges we have to solve. So we have to come out with a solution that we take out of this range anxiety, provide infrastructure and so many things. Now one of the aspect, the cost aspect of battery electric vehicles is the basic cost of, if you really look at when we speak to customers, the ICE customers today who buy the diesel vehicle or the gasoline vehicle, they are more or less convinced yes, electric vehicle they should buy. But then when we talk to them, they say, boss, ये cost बहुत ज़्यादा है. Battery अगर replace करना पड़ा in between, then what to do? What is the cost of battery replacement? That is something not possible. So hence they prefer go for conventional petrol diesel vehicles. But the cost of the battery, which we had earlier about 10 years back, and now it's drastically changing. It is reducing. Now we expect that in India we got lithium reserve found out in Kashmir or some other places. So obviously we hope that battery cost will go down. And that will become more economical and will help every person to own an electric vehicle than traditional vehicles. And that's what the future looks like. Now let's see something about quickly move on. Now let's look at the advanced driver assistance systems and ADAS, autonomous driving. Now why there is a pull for ADAS and autonomous driving? So really look at about from the data which is published by the US National Highway Traffic Safety Administration, says 1.3 million people worldwide die every year, 1.3 million, as a result of road accident. And out of 94% accidents are due to human errors, driver errors. So that's the statistics. That's why the pull towards autonomous is. Because humans tend to make mistakes. We already know, we already heard he was driving, then he got fatigue and lost the control. So over there, basically the ADAS and autonomous vehicles are taking over. So ADAS is basically a system which supports the driver to drive while avoiding the possible human errors. So ADAS uses a different set of sensors to perceive the world surrounding the car and then provides information to the driver as and when required. Autonomous vehicle is a self-driving vehicles generally. So when autonomous vehicle comes in, probably then we can be really relaxed and just sit in the car and let everything done automatically drive. I can chat with friend, I can take rest while driving, I can do some business meetings, anything. Now there are different level of autonomous classes are defined as a SAE, like SAE stands for Society of Automotive Engineers. So start from level 0 to level 5. Well, level 0 is nothing, like we just is very like some only warning it gives, some kind of thing. But level 1 onward, basically it starts with whether it will use steering assistance or acceleration support kind of thing. Detail we'll see in the next slides. This is just give you the overview of what are the levels internationally defined. Level 2 is a combination of both, like you have the longitudinal control, lateral control, like steering and braking together. So it will assist. Level 3 is a traffic jam, like you can give the control to the system for some time. But you have to be alert, like anytime you should be able to take the control back. That's the level 3. Level 5 is in confined area, defined area, you can give the control to the car. For example, London taxi. In London, there are autonomous taxis are being used. So over there, the defined area is being mapped. In this area only it will work, kind of thing. So that's the level 4. And level 5 is something you can just sit and relax. There is no pedal, there is no steering, there is no brake, there is no gear, nothing. Just you are sitting like at home on sofa set, you can sit in the car and the car will take you out wherever you need. Now of course the automation, now we say it sounds very funny that okay, that kind of automation is going to happen, but it's not easy task. That's how the engineers, the scientists have worked, and they have defined what is required to make the vehicle more autonomous. So, of course, the complexity, as we move from level 1 to level 5, the complexity of the system is going to increase. Now, mainly in level 1, like for example, adaptive cruise control is a one. Like my car able to adjust the speed automatically depending upon the vehicle in front of me. So that's a adaptive cruise control. Like lane keep assist. If I'm drifting, changing the lane, it will alert me, something like that. So over there, generally, the radars are being used for this purpose. The basic minimum 3 radars are required to enable the level 1 automation. Level 2 is a mix of, as I said, the lateral control and longitudinal control, both. And it uses more than 3 radar and at least 1 camera. The level 3 is high automation, where more than 6 radars, 2 cameras and 1 lidar is being used. And they are basically traffic jam assist, highway pilot and remote valet parking. This kind of features are being offered under level 3 automation. So level 4 more and more complex, but it can communicate, it can remote driving, remote assistance, everything. These are the features of level 4. And more and more sensors are being used. Level 5 is something fully autonomous, no driver there is no driver required. Everything is automatic. Then system is more complex. Again, the sensors, more and more sensors are required. Now, if you really look at, if you have to imagine a autonomous car in India, and suppose it has to drive in Manipal city, where we have all sorts of characters on the road. Characters means what I mean, the objects on the road. Like you have two-wheelers, you have pedestrians, you have cyclists, you have animals, and four-wheelers, and so many things. Then traffic, sometimes traffic light is there, road marking is there, not there, so many things are there. But the car has to take decision in such environment based upon the sensor only. So that kind of accuracy, that kind of data processing, that kind of intelligence is required. And that's how the engineer's job is. So more and more fine-tuning, calibration of the system is essential. And that's what's going to happen. Now mainly what, yes please.
Sir, how many of these sensors can we expect to be outsourced to infrastructure? Because we have so many sensors, so all of these.
Can you use the mic? I'm not able to hear.
Right, am I audible? Right, so how much of these systems can we expect to be outsourced to the infrastructure surrounding the car? I mean, cities and such. So you have so many sensors on board the car, right? How much of this can we expect to be implemented into the infrastructures, like sensors on the roads or on street lamps? So how much of it can we expect it to be offset into the infrastructure itself instead of expecting the car to hold everything?
So there is some borderline actually. There is some line has to be drawn. Now the things which are basic essential for car to drive, correct? On any type of road, not necessarily in the city, not necessarily it can be highway, it can be village area where there is no sensors. Like when you talk of infrastructure sensors, probably in city we can do, as I say, level 4 in London city. In confined area, the infrastructure has been created such a way that it enables autonomous driving. But still, the car, so over there it's okay that as far as the car is going to drive in that confined area, it's okay. But you and me, if I'm going to drive autonomous car, we are not going to limit ourselves in that area. We are going, definitely will go on highways, we'll go on outskirts, we'll go in countryside, so many things. No infrastructure sensor would have that. So, the basic minimum requirement the vehicle has to carry. Absolutely, there is no excuse, there is no other. This is what basic requirement. Because the car has to qualify, the car has to pass the regulation. See, autonomous car is not so easy. Like, I put 100 sensors and I'll declare autonomous car. No, it's not. You have to, government regulations you have to follow. You have to pass certain tests and conditions. So bare minimum sensors are required on the car. That's how defined by SAE level. We saw some sensors, numbers, radar, lidars are required. This is defined by SAE. This is what basic minimum you require. Over and above that you put whatever you need. So that basic numbers are required. And of course, the transport system has to be intelligent in order to make it more effective. Only car making autonomous is not going to help. The signal should also be able to communicate. The road signals which are passive today, like speed limit, no parking, signboards, signage we see on the roadside, those are also needs to be smart enough to communicate to the car. Today they are not, but tomorrow they will happen. Understood you. I hope I answered your question.
Yes, sir.
Then I said the 3 type of sensors, lidar, radar and cameras being used. Now this is a sensor, what we can see is the output of this is camera output and this is a lidar output. This is what lidar output looks like. Okay. Of course there is a radar also being used, but radar is for longer range radar won't work much. So for longer range the lidar is more effective. And if you look at this here the same image scanned by lidar and radar, you see the resolution. So this is what the clarity we have in lidar output. The radar won't give that quality of signal. But then all this sensor has to be, the system should be able to integrate, like we call it sensor fusion technology. So certain things are good in camera, certain things are good in lidar, certain things are good in radar. So that has to be the positives of each has to be used and to create a environment which driver sees, or vehicle sees, what I mean actually, and based upon which vehicle able to take decision. That's the sensor fusion technology being used in the ADAS vehicles and autonomous vehicles. So these are some of the features for ADAS technologies. Now autonomous vehicle, like how they use different features, which sensors they use, this is what information it gives. Like radar, lidar are being basically used for emergency braking, pedestrian detection, collision warning, adaptive cruise control. Then cameras we use traffic light recognition, lane departure, surround view, park assist, then ultrasonic nearby the car, like reverse park assist, blind spot detection for that purpose. So depending upon the feature and sensor, effectiveness of the sensor, these are being sent, the output of the sensors are fused to derive the necessary information. So I'll skip this video because there is only video, you can see it on internet as well. Yes, please.
Good afternoon, sir. My name is Tarini. I had a question
Just
regarding...
use the mic, please.
Hello. Good afternoon, sir. My name is Tarini. I had a question regarding the autonomous side of vehicles. For example, there is a use of technologies like steer-by-wire and brake-by-wire, right? I was just wondering how exactly that kind of technology is more helpful in a situation where you want to completely autonomously drive a vehicle as compared to normal mechanical, inputs.
True. See, when we say autonomous vehicle, meaning is this technology are already in place, then only the vehicle can be autonomous. See, the vehicle has to be, generally today we have the acceleration by wire, like drive by wire, feature is already there. There are no more mechanical pedals are there. It is driven by wire only today. So tomorrow the brake by wire and the steer by wire, these are the basic requirements for autonomous vehicle. Those are must. Then only control would come automatically. The mechanical linkages has to go away. Okay? Now, as we seen that more and more software, so there is a threat of cyber security attacks. Now, you must have been read about it. In 2015, two security researchers remotely hacked into Jeep Cherokee, driven by journalists, and took control of its steering, brake, transmission, radio, windshield wiper, and air conditioning. They exploited the vulnerability of the Uconnect, their onboard connected car platform, to attack on the Jeep Cherokee. So this was happened in 2005. Recent example in 2020, Tesla Model X, which was hacked by researchers from the University of Leuven, Belgium, actually. So they showed, basically the intention was not to really create some havoc out of it, but just to highlight the vulnerabilities the automobile today we have, more and more connected, more and more autonomous software, and then highlight to the OEMs and government. That's how it's happening. So there has to be some regulation and system protection in place. Now, so many attacks are taking place. Like if you really look at over a year, so this plot shows so many attacks have happened in the automobile. The another side effect of autonomous or more and more software or mechatronic systems is electromagnetic interference. So we heard about emission, tailpipe emission, noise emission from automobile. This is another emission, electromagnetic interference. So this is the fourth largest emission now for automobile. The third emission is the brake pad and the tire particle emission. That is the third emission, which is being controlled now. Definitely something will come on electromagnetic interference also. Today, of course, there is some regulation in place, but that is only for safe working of the car. So, one example here, like the Toyota in 2009 and 2011, the Toyota unintended acceleration case happened. So, vehicle used to suddenly accelerate without any driver input. When this case was investigated, then it was found that the throttle body controller, basically it's accelerator control, that was getting influenced by the interference caused by nearby ECUs. So the nearby ECUs generating some interference, EMI, electromagnetic interference, that was affecting on the functioning of the electronic throttle control unit, and that was creating this problem. So this is another side effect, we can say, which needs to be addressed, and which is a growing concern. As more and more electronics coming, these kind of problems would come. This is my last slide. So what we see that so far we were worried for decades about weapons of mass destruction. Now it is a time to worry about
not very frequent charging point. So, sir, for the next 4 to 5 years, aren't the hybrid cars better for the first time buyers?
see what is good and what is bad. It depends upon the intention of usage. So there is no single answer what is good and what is bad. So my requirement is different than your requirement and different than the third person's requirement. So what suits best, that is the technology we have to use ultimately. So now for example, the hybrid car, so it depends like what motivation you have, correct? So if you really look at the electric vehicles today, of course the range is limited, but if I am driving in the city, like out of 365 days of a year, I use my car about maybe 300 days in a city only, and in 65 days I go outside beyond 400 kilometer range. So still I prefer electric vehicle because 300 days I can use it comfortably. That saves a lot of money for me. And whenever I go out, I share the Ola, Uber, I take taxi and go for 65. It depends upon. If someone has, daily I have to go out of 400 kilometer range, of course. Then the requirement is better to use the ICE technology today. It depends upon, that's it, the objective.
So we can take the question answer list immediately after the session. Due to time constraint, we have to stop here. So I thank Mr. Santosh Gosavi sir for giving a very informative and educative talk. I'm sure everyone will be able to connect to it due to the practicality of it. So I request our HOD Dr. Sisha to give a certificate of appreciation for our chief guest.
Unfortunately, we are running short of time. Because return flight is at 4:30 and we have to leave by 1:15 from this hotel room. Because of that, we are cutting short the interaction time. But anyway, any questions you are having, you can communicate to us. We will share with him and get back to you. Okay? So the talk was very informative and very relevant for the electronics and instrumentation, especially cyber physical system students who have come to attend this session. Especially, I thank Professor Santosh Gosavi for giving this very informative talk to students, and we are very much benefited by this. Thank you.
So next we have a session at 2 p.m. by Professor Sudesh Sivarasu from University of South Africa. So students who are free are requested to join the session here in the MS seminar only. Okay, 2 to 3 p.m.